let's look at a different application of factoring. Suppose we have a rectangular prism. Now we have 3 dimensions. Because the volume of a rectangle can be found by multiplying, the volume of the rectangular prism can be found by multiplying the length, the width, and the height. There are now 3 dimensions, which means there has to be 3 factors. Suppose we know that the volume of this rectangular prism is 18. Well, remember at the beginning when we broke this down into its smallest factors, 2 times 9 makes 18. 9 is 3 times 3. So that means the length must be 2, the width must be 3, and the height must be 3. Now, suppose we don't know exactly how big the rectangular prism is, and instead we just have an expression, 2x squared plus 2x minus 24. Is there an integer that all 3 terms can be divided by before we begin factoring? If so, this is one of your factors, which is why there are 3 factors in 3 dimensions. What can 2, 2, and negative 24 all be divided by? Well, that means your greatest common factor is 2 because all of those things can be divided by 2. So we first factor out the greatest common factor, and that leaves us with x squared plus 1x minus 12, because 2 divided by 2 leaves us the invisible 1. 2 divided by 2, again, is 1, and negative 24 divided by 2 is negative 12. Now when I identify my A, my B, and my C, I switch to the new A, B, and C. So A is 1, B is 1, and C is negative 12. I already know one of the dimensions. I know that one of the dimensions is 2 because 2 is going to be one of my factors at the very end. So now I need to go ahead and multiply A times C. 1 times negative 12 is negative 12. I'm looking for 2 numbers that multiply to be negative 12, but add to be 1, add to be B. And so that has to be negative 3 and 4, because negative 3 times 4 is negative 12, and negative 3 plus 4 is positive 1. I rewrite my trinomial. Remember, we are replacing B with negative 3x and positive 4x so that we can have 4 terms so that we can factor. This is my first group. That's my second group. The first group has an x in common, so this becomes 1x minus 3. The second group, both terms are divisible by 4, so that's also x minus 3. Now we have 2x minus 3, so that's one of our factors, and what's left over is x plus 4. That is not my final factored form, though. That's the factor of the new trinomial, but I have to include my 2 in my final factored form. So if I'm looking at my lengths here, if one side is 2, that means one of these sides is x minus 3, and the other one is x minus 4. So let's try some without the rectangular prism. We want to always look for a GCF first. So what can 6, 33, and 63 all be divided by? Well, all of those things are divisible by 3, so my GCF is 3, and I'm going to start by factoring that out. That leaves me with 3 times 2x squared plus 11x minus 21, because 6 divided by 3 is 2, 33 divided by 3 is 11, and 63 divided by 3 is negative 21. Now this is my new A, this is my new B, and this is my new C. So I'm not doing negative 63 times 6. Instead, I'm going to take negative 21 times 2. That gives me negative 42, and I'm looking for 2 things that multiply to be negative 42 and add to be 11. So we go through our list, 1 and 42, 2 and 21. Let's see, what's 42 divided by 3? 42 divided by 3 is 14. Oh, I see if I subtracted 14 and 3, I would get 11. So let's think about which one of these should be negative. I see 11 is positive, which means the larger number should be positive, which means 3 is negative. I'm not going to worry about that GCF of 3 until the very end. I'm going to rewrite my trinomial using the magic numbers. I could write this as 14x minus 3x, but I like to put the negative first because that causes me to make fewer negative errors. Don't forget, we have replaced our C as 63 with 21 here. Now we're going to do our first group and our second group. The GCF of the first group is x, so that leaves me with 2x minus 3. The GCF of the second group is 7 because 14 and 21 are both divisible by 7. 14 divided by 7 is 2x. 21 divided by 7 is 3. I know I've likely factored correctly because my parentheses match. So this becomes x plus 7 times 2x minus 3. And my final factored form includes my 3, so it's x plus 7 times 2x minus 3. Right now, I want you to pause the video and try this one on your own. Don't forget to start looking for your GCF. Welcome back. You should have said that your GCF is 2. So we're going to start by factoring out a 2 from everything. So 6 divided by 2 is 3. 4 divided by 2 is 2. And 10 divided by 2 is 5. This is my new A, this is my new B, and this is my new C. I'm going to multiply A times C, so that gives me negative 15. I'm looking for two numbers that multiply to be negative 15 and add to be negative 2. Those numbers are 3 and negative 5. Negative 5 is negative 15, and negative 5 plus 3 becomes negative 2. I'm not going to worry about my 2 until the very end. I'm going to rewrite my trinomial as 3x squared minus 5x. Remember, I like to put my negative first so that I make fewer negative errors. Minus 5. Because of the way I've set this up, we don't have a GCF for the first group other than x, which is okay. 3 and 5 are only divisible by 1, but x squared and x are both divisible by x. If I had 2 here and I take 1 out, that leaves me with 3x. If I had 1 here and I take 1 out, that just leaves me with the minus 5. I have to have something here. Remember, we said 3 and 5 are both divisible by 1, so we're going to put a 1 in that blank. Other than that, there's nothing else that those two terms can be divided by. The common factor now becomes 3x minus 5. We cross that out, and that leaves us with x plus 1. Bring this down for our final factored form, which is 3x minus 5 times x plus 1. Good job. Now, what if we have a binomial? Suppose we only know that the volume or area of the rectangle can be found with the expression 2x squared minus 18. Is there an integer that all three terms can be divided by before we begin factoring? Excuse me, all two terms can be divided by before we begin factoring. If so, then we are finding the dimensions of the rectangular prism. If not, we are finding the dimensions of the rectangle. Well, is there anything that 2x squared and negative 18 can both be divided by? There is. Our GCF is 2. That means that we are not finding the dimensions of the rectangle, we're finding the dimensions of the rectangular prism. So now we're going to take that 2 out, and that's going to leave us with x squared minus 9. Since there was a GCF, we have to find the dimensions of our rectangular prism. Remember, we already said that one of them was 2. We have to factor by replacing b with 0 because we have to have a trinomial to find the magic numbers. Right now, what I have is 2 times x squared minus 9, like this. That's what we were left with. A is 1. I don't have a b because there is no x term, and c is negative 9. Well, the number that represents nothing is 0. So what I need to do in this case is replace the middle term with 0. Now I'm ready to follow the same set of steps as I did before. I'm multiplying a times c. I'm looking for two numbers that multiply to be negative 9 but add to be 0. The numbers have to be the same in order for that to happen, but one should be negative and one should be positive. So now you're left with x squared minus 3x plus 3x minus 9. We factor out the x from both pieces, so that's x times x minus 3. Factor out the 3 from both pieces, so that's x minus 3. That leaves me with x minus 3 times x plus 3. Don't forget GCF was 2, so that means your dimensions are x minus 3 and x plus 3. Good job. All right, so let's first check to see if there's a GCF. The 12 and negative 27 can both be divided by 3, so I'm going to factor out a 3. That leaves me with 4x squared minus 9. Remember, I need to factor with a trinomial, not a binomial. So I'm going to take my binomial, I'm going to keep a and c the same, but I'm going to replace x with 0. Now I'm looking for two numbers that multiply to be negative 36, but I need them to add to be 0. Those numbers are 6 and negative 6. So I rewrite those as 4x squared minus 6x plus 6x minus 9. We're going to break those down into two groups. The GCF of the first group is 2x because 4x squared and 6x are both divisible by 2x. 2 is 2. X squared divided by x is x. 6 divided by 2 is 3. The x divided by x cancels. GCF of the second group is 3, so that becomes 2x minus 3 because 6x divided by 3 is 2x and 9 divided by 3 is 3. These match, so this becomes 2x minus 3, and what's left is 2x plus 3. But don't forget, I had an original GCF at the very beginning, so that has to come down because that's a part of my factors. You go ahead and pause the video and try example 2 on your own. Welcome back. You should have said that your GCF was 2 here, and so you should have started by factoring that out. That leaves you with x squared minus 16. Now, we can't factor with a binomial. We have to rewrite this as a trinomial. We're going to replace our x term with 0x. And now we can go ahead and proceed. We do negative 16 times 1, which is negative 16. I'm looking for two numbers that multiply to be negative 16 but add to be 0. That has to be negative 4 and 4. I rewrite my trinomial using 4 terms. I replace the 0x with negative 4 and positive 4. And I'm going to break this up into 2 groups. The GCF of the first group is x. When I divide, I'm 4. The GCF of the second group is 4. When I divide, I'm left with x minus 4. That leaves me with x minus 4 times x plus 4. Don't forget that the original GCF was 2. That's it for now. So go ahead and go back to your haiku page and find the IP on the factoring review and work your way through that. Don't forget that if you're having trouble, you can always come find me in my office hours and we can work on it together. Have a great day.